Okay, so we are talking about proving triangles congruent by side angle side, or SAS. In the past, we had to prove all 6 things in the triangle were congruent. We had to prove that all 3 sides were congruent in both triangles and all 3 angles. But now we have a shortcut called SAS, or side angle side. So when we look at side angle side, we're looking at if 2 sides, so in this case it would be AB and FE, so the yellow ones, if those are congruent and the green ones are congruent, so BC and ED, as well as that included angle. So the included angle is the one that's right here where the 2 congruent sides come together. If all 3 of these pieces are congruent, then we can say that our triangles are congruent. So when we're looking at a proof, we need to figure out how to prove that these 2 triangles are congruent given that information. Okay, so I've already included the given information for us here. BC congruent to DA and BC is parallel to AD. So I've marked that on the diagram as well. Now, going from here, if we notice that we have our parallel lines here, we have BC parallel to AD, and then we have this transversal here, we're actually creating alternate interior angles. So these guys here, BCA and CAD, would be congruent. So I went ahead and included that information for us here, that these angles are congruent. And remember, we're trying to prove that those 2 triangles are congruent. So I have this pink one here, and then I also have this blue one. And we notice that both of these pink and blue triangles actually share that side there, AC. So because that's shared, we can then say that that's congruent by the reflexive property. So now if we notice in our 2 triangles that we've created, that we've seen, we have ABCs, we have a side, an included angle, and then another side. And then if we look at the other one, ABC, we have a side, the included angle, and another side. So because of that, we can prove these 2 triangles are in fact congruent by side angle side. So when we write side angle side, we just need to write the 3 initials, SAS, to show that these 2 triangles are congruent by that. Okay, go ahead and try this one on your own. This one's going to take a little bit more information, thinking about RO being that perpendicular bisector. So go ahead and pause the video, work out on your own, and then come back and check your answer. So as you can see here, we were told that RO is the perpendicular bisector, which we know then cuts FL into 2 congruent pieces. We also know that we're forming right angles here, so both of these angles have to be congruent because all right angles are congruent. And then RO is shared between both the pink and blue triangle, so we know that both of these lines are included, they're the same line. And then we can say that FRO, that triangle, the pink one's congruent to LRO because of side angle side. So the next thing I want to talk about isn't necessarily a slide in here, but it's called corresponding parts of congruent triangles are congruent. So what that means is that in these 2 triangles, although I haven't necessarily proven that angle F is congruent to angle L, once you've proven the 2 triangles are congruent, I can then say anything is true about those 2 triangles. So I could say next, so if I were to continue on, I could say my 6th step could say that FR is congruent to LR. And we know that because once these 2 triangles have been proven congruent, I can say that FR, so this guy here, has to be congruent to this one over here. And the reason would be because corresponding parts, so these guys are corresponding in the 2 triangles, these triangles are congruent, therefore they have to be congruent. And that's a lot of words to write out. Corresponding parts of congruent triangles are congruent. So we actually abbreviate it to corresponding parts of congruent triangles are congruent. So we use the abbreviation CPCTC corresponding parts of congruent triangles are congruent in order for us to say other additional pieces. So again, this is not part of that proof. It's just there for us as an extra piece. Okay, so the last thing we're going to talk about is just a quick review of equilateral and isosceles triangles. So take a second, pause the video, and read over this theorem. We talked about it before. And do the same thing here. Go ahead and pause the video. We've talked about this one before as well. So now what we're going to do is we're going to prove this is true, and you're going to see how these things are related. So we're going to first start out with our givens. So we started out with AB being congruent to AC. So now what we've actually done here is we've drawn this line AD so that it's the angle bisector of that angle A at the top. So this line AD is cutting this and so that these angles here are congruent. We don't do this often, but since we're proving a theorem, that's why we needed to draw in that line. So you will not normally do that in a proof. So I just wrote this as we're drawing AD as an angle bisector, and I can construct any line. So now because we drew this thing as an angle bisector, I know that BAD, that angle, is congruent to CAD because of the angle bisector. And we also know that in these two triangles, BAD and CAD, that line AD is being used in both. So as you can see in these two triangles that I've drawn separately, we have this side, the included angle, and the other side right on the other side of that angle. So we know that these two triangles are congruent by side, angle, side. So since these two triangles are congruent, we can say that anything else that we haven't already proved congruent is congruent. So we're trying to prove that angle B is congruent to angle C. Well, and it just so happens that in our congruent statement that angle B is congruent to angle C. So I can say angle B is congruent to angle C, and that's because corresponding parts of congruent triangles are congruent. And lastly, to round this out, go ahead and try this problem on your own. You can go ahead and pause the video and try to solve for X and Y. The answer is on the next slide. So once you pause the video, work through it and then check your work. And here's the answer. So now we've talked about side angle side congruency. We're going to be talking about a few more in the coming days.